All right, guys. There are 5 steps. I understand. And again, it used to be 8, so you're welcome. A couple of them are exactly what we've done before in this class. But also a couple of them are, there's a lot of new shit kind of in there, right? So I understand it's going to take a little while to kind of get used to this. But hold on to the most important part. It's sort of like if I was a football coach and my team is slow as shit, I want to recruit somebody who's got some speed to them. So I'm going to hold tryouts. And what am I going to set to kind of see who I'm going to take on my team? I'm probably going to set a benchmark time for a certain amount of distance, right? Depends on if I want a sprinter or if I want like a long haul dude, right? Yeah. So I'm going to set, you guys with me? You're going to set a benchmark. That is like the 2.326, the benchmark. And then if they get better than benchmark, I might think about them for, and if they don't, bye-bye. Right. Do you understand? So it's like I reject you or I fail or I accept you. You know, does it make sense? So that 2.326 is a benchmark. Your sample's got to get past that to show evidence that the middle's in the wrong place. If I get past it, I can reject the hoe. That's the one that thinks the middle is it. Right? And if I don't get past that, I fail to reject the hoe. Right? All right, I like it. Yes?
I think I understand most of it.
When he doesn't
What is the
reject the hoe.
significance of the area above or below in a different situation of our Z-star?
All right.
0.0031.
All right, ready?
I just understand the significance.
To be honest, the most important thing in there is that number. And I'm going to show you an example from that study we were looking at before. What you see in journal articles, in real life, to really come clean with you guys, you're not given an alpha. Because where the hell would that come from? Everybody that reads your article will have their own personal benchmark. What shows enough evidence. So what you report instead is the p-value. So now let me see if I can make this next part make sense.
So that's the p-value.
That's the p-value. Yeah, that's, I had it up here. There it is. The p-value. The area in the tail of your z-score that you calculate. Okay. So, now watch this. Let me put this up here. It might be easier for me. Oh, you guys love this shit. This is yummy. All right. Yes, I love that. So, we drew this, right? Right? Okay. Where's alpha? Where's alpha on that picture?
Right.
Yes, alpha is the area of the tail of the critical z-score. This is what, I think the book uses that language. Critical score. Like they call it ZC, if I remember. That's just that benchmark score we look up. This is alpha. And here it was 0.01, correct?
Yeah.
Everybody with me so far? So alpha goes along with that critical z-score, that z-score I compare to. Z-star has its own tail, but I can't call that alpha, so we call it p-value instead, just because they had to pick something, and some idiot said that, so they chose it. Now, do you see, if I'm in the rejection region, what's going to be true about this p-value compared to the alpha? If I'm inside of it, is it a bigger or a smaller tail? Smaller. So if the p-value is less than alpha, I reject the null. But I'm hoping you guys realize that's the same thing as saying if my z-star is bigger or further than this critical z-star, I reject the null. Those both are the same thing. If I'm further away, isn't my tail smaller? If I am further away, isn't the tail I make smaller? I got less stuff out there. Because I'm ignoring this much stuff the other guy's got. So that's why in journal articles, what you see, poor little dude. Let me switch over to the journal article real quick. What you see reported always. Let's find my Harry Potter. Yeah. Is it up here? A lot of shit. Here we go. Oh, there's one right there. All right. Let's see if we can make semi-sense of this. Alright, see this right here? In line with predictions, the expected two-way interaction between Harry Potter books read and identification with Harry Potter was significant. P less than 0.05. Let me see if they have a different P somewhere. I'm not sure what they mean by that. Look, here's P less than 0.01. Here's P less than 0.001. So you report that P less than 0.01 is pretty damn good. That's significant. P less than 0.001 is like, holy shit. Every time you have a smaller p-value, that's the probability that your sample just happened randomly versus the middle's in the wrong place. So the smaller that is, the further out your sample was. The more evidence that is that the middle's in the wrong place. So a small p-value is significant.
Small p adds credibility.
See it?
Small p-value adds credibility to the
Yes, I like it. And this is all evidence, never proof, because it really is a chance that you're wrong. Yeah.
P alpha, the p value is greater than alpha. Would you accept HI? P value is greater than alpha. Like you said right there.
If the p-value was bigger than alpha,
Yeah.
then I didn't make it in the rejection region. I would fail to reject the null. I would fail to support the high. There was a place here where the p-value was big, but I forget where it was. Hold on. Look at all this data. Oh, yeah. Here, look at this one. P equal to 0.13. Look, I love this. Okay, here we go. Right here. For those more identified with the negative character, the relationship between Harry Potter books read and perspective was non-significant because P was so freaking big. 13% chance, that's not unusual, right? That's not less than 5% or less than your personal feeling of what unusual is. So in a journal article or a study posted somewhere, they're going to report the p-value. Because then everybody can say, well, that's significant or that's not significant. So 0.06 p-value, some people would go, yeah, that's okay, and some other people go, that's not good enough. But it's up to them. They can make their own decisions. Which, if you think about it, makes sense, because there's always a chance that the study is wrong. Not because anybody did something wrong, but just because of random happenstance. Maybe. And that's where I lose some people. They're all like, math's supposed to be concrete. No, not really, to be honest. Normally the math you learn is just like the beginnings of being able to do what real math is. You're starting to get a feel of what real math is. Okay. And you're all like, I've had enough. Well, not yet. You're not done yet. Okay. Does it make some sense right there? I mean, let's finish this problem up, and then we have some time for you guys to try one on your own for real.
I tried it. Let's see if I did it right.
You're gonna try that one, but let's finish this first one up. We haven't finished this.
Conclusion.
The conclusion.
P-value.
Right here, what can I say right here? Real quick, did we make it far enough away?
Yeah.
Yes. So we can reject the null. Support the high. Right? Now help me out. The very first thing you're worried about in this kind of problem is the claim. The very last thing you worry about is the claim. Which one was the claim, the ho or the high? Which one was the claim?
Oh, hi.
Remember this? There's the claim. Which one is it? The high. So what language am I going to use? This language. Our conclusion should be about the claim. So which language am I going to use? Everybody okay with the fact that this is one situation? If I think this guy is wrong, that means at the same time I think this guy is right. This isn't two separate things. This is one thing. But which way do I state my conclusion is which one was the claim. I got to talk about the claim. Whoever made the claim is like, well, was my claim right or not? So my conclusion better tell him, you're right, you're wrong, whatever. So here's how it goes. So we made it, right? We succeeded. So we have found. Oh, you're going to love this shit. we have found sufficient evidence to support, don't you dare freaking say H1, support
The claim.
the claim that what? What did the claim say in words? The claim that,
The mean lifespan of all coyotes in the wild.
yeah, the northern Minnesota coyote lives longer in captivity. You can just steal the language from the problem. I'm not going to ding you on plagiarism or some bullshit. As long as you write it in physical terms, so what's going on, don't just say, we support the claim. No, we have sufficient evidence to support the claim that the northern Minnesota coyotes live longer in captivity. Or you could state it in a way that brings in the 7.25 years if you want to make it more specific. As long as you captured that idea, golden. And again, we just started this. Now, of course, by Monday I'm going to be calling this old news, but try to do the problem on the flip side. Yes?
So would a correct conclusion statement would say that the p-value is 0.30 or 0.0031, the actual hypothesis studies into the last step.
Because it's not referencing the claim. So your conclusion has to reference the claim.
Okay, so if the claim is then on the hypothesis.
Then you would have been okay, but you bring more of the physical language in instead of H whatever, null, whatever. Just bring the actual language. Yeah.
What is the point of business? And then the other question.
Well, if I don't get that, I don't know if my sample is anymore.
Okay. Second point is, how do we know if this is 99%, 90%, 85%? What the fuck?
I don't understand. If that's 0.01, and that's the amount in the tail, then that has to be 99.
Then
So
it's
this
less
will always
than
be
38.
That's the total in the tail or tails.
Yeah, that would be
And why do you need to know that? 0.01, one tail, one tail.
the things I'm trying to say is, this thing would tell us how much confidence they have in their own like for people who test it to 7.5, yeah. Based on the specific results, that would tell us
So they're saying it's not
how confident they are. You know what we're doing here? We're finding out how confident
38.
Yeah, it's kind of related to confidence in a way. That would be related to a 98% confidence.
Yeah, or 99%.
No,
Well, I mean,
because confidence would be 10.
yeah, this is one thing.
I know, so it's not really related to confidence interval, is it? Confidence intervals are always 2 tails, right? Yes. But you've got
How do we
the
know
right
this is
sort of
one
idea.
How do we ever know it's one tail or two tails?
Because it is.
Because of
The
this.
only time it's 2 tails is if that's not equal to. Not equal to. If it's not equal to, that means it could be up or down. That's the only time it's 2 tails. Oh, this stuff here. Let's see if I got any blank ones. Yeah. This here.
Yeah.
And you got the T chart, right?
Yeah.
Okay.
Thank you. Why is it being